Okay, so today we're working on a Pythagorean theorem again. Today we're going to focus on how can I tell if three given side lengths can make a right triangle. We're going to use the Pythagorean theorem, a squared plus b squared equals c squared, obviously. Let's look at the next slide. And there's our Pythagorean theorem. We've talked about that a and b are going to be our shorter sides. Those are going to be our legs. And that C is our hypotenuse, which is always our longest side. So we can tell if they give us these three lengths. We just need to look at the longest or largest number and know that that's our longest side. And that is has to go in place of our hypotenuse or our C. The other two, A and B, it really doesn't matter the order as long as they are in those spots. And then what we're going to decide is, do they make right triangles or not? And how we figure that out is once we plug the numbers in, we have to see, does the sum of the squares of the legs, so that's important that you look at that. You understand, it's not just the sum of the legs, it's the squares of the legs. We're using that Pythagorean theorem, is equal to the square of the hypotenuse. All right, so if that is true, if we plug our numbers in and we see that that is true, then that is going to make a right triangle. If we plug it in and they are not equal to each other, then we see that that is not a right triangle. And it's going to depend on the different questions, how they ask things. Are we looking for ones that do make a right triangle or ones that do not? All right, on this question, we went through and looked at, it says, they give you a picture and it says he would like to know if this is a right triangle. How can he make that determination? So it's kind of what we just talked about. This one's just really asking for an explanation of how could he tell if it was a right triangle or not. We went through these choices and looked. Choice A says he could add the two shorter sides, and if their sum is equal to the longest side, the triangle is a right triangle. Where the problem with this is that they only say if he could add the two shorter sides and their sum is equal to the longest side. Well, we're missing something there. We're missing the squaring of the shorter sides and the square of the longest side. You've got to square them. You can't just add them up like that. So that's why that was not our answer. Choice B says he could add the three sides together. If they equal 180, the triangle's a right triangle. Well, 180 doesn't even deal with sides. 180 really deals with angles. So that explanation did not make any sense. The next one says he can find the sum of the squares of the two shorter sides, and if that sum equals the square of the longest side, the triangle is a right triangle. And that's what we just said. That's what the Pythagorean theorem means, is that you will square those two shorter sides, add them together, which is what sum means, and it's got to equal the square of the longest side, which is C. All right, the last one, it honestly doesn't even make any sense. It just says the sum of the square of the longest and middle length sides, and if the sum is equal to the square of the shortest side, that's a lot. So that's definitely not your answer. So C is your answer on this one. All right, on this one, we were looking for one that is not a right triangle. So if we're looking at these, we've got to plug it into our Pythagorean theorem. We make sure we look at our pictures and choose our longest side, because that we know is going to have to go in place of C. So that's what we did first on each one of these pictures. Then we plugged it in our Pythagorean theorem. You can see right here we plugged in for this first triangle. We plugged 6 and 8 on the sides for the legs, 10 in the side for the hypotenuse. When we multiplied or squared those and got the 36 and 64, we added it together and we saw that it did equal the right side. So that one was a right triangle. Remember, this one says which one is not. So that's why we didn't choose that for our answer. B, we also plugged in the numbers here. We saw again that it equaled, so that means that is a right triangle. So it is also not our answer. On C, when we multiplied and added everything up, we got 697 was equal to 625, which is clearly not true. So that tells me it is not a right triangle. The last one did end up 841 is equal to 841, so it was also a right triangle. But your answer, since we're looking for one that does not, then it is C. All right, on this one with the, they give it to you just in different representations, same kind of thing. This time we're looking for one that could represent a right triangle though. So we went through each person and they're identified by the first letter of their name. And first thing we did was go look through the side lengths and make sure we chose the largest one and put that in place of C. So you can see for Galen, we did 10 squared plus 20 squared equals 15 squared. That gave us a final of 200 is equal to 225, which is not true. And remember, we're looking for one that is, so that's why it's not your answer. Denise plugged in everything, found 14 was the largest, so it goes over here. Plugged it in again, 244 equals 196, not equal, so not a right triangle. Peyton, we saw that 26 was the longest side, so that's why we put it for C. And then when we multiplied this all out, it gave us 676 is equal to 676, which is true. So that one is our answer. And we went ahead and finished out Wesley to show that it definitely was not our answer either. So Peyton, final answer on number 3. All right, on this question, they said, which could be the side lengths of a right triangle? Select all that apply. So that told me we had to check every single one of these. So you can see on the screen, we worked out each one. If it was not equal, we did not choose it because that means it's not a right triangle. So A was not your answer, neither was B. C, when we worked it out, we see they do equal, so that was one of our answers. But again, when the select all that apply comes up, it's probably more than one. So we're checking everything. D, if we look at it, it's definitely not equal. And I told them, if you notice how small these two numbers are, both of these numbers are, and big this one is, that's never going to equal out. But when you have one of kind of a smaller and a larger number, and you have a larger number over here, that's a possibility. And when you do that last choice, you see that it does equal out. So your final answers on this one should be this third choice and this fifth choice. We labeled it C and E. All right, this one I told them can be a little confusing, but they love to use letters and ask you to solve for one specific variable. So I told them to think about it as if we were working this out and we were missing a leg and we had to solve for A. Ooh, excuse me. So we had to get A squared by itself first. So the first step was to subtract this B squared to move it to the other side. So it's gone. Then we had A squared equals C squared minus B squared. Well, I told them we were trying to solve for A, not just A squared. So that's why we had to take the square root of both sides. We bring down our A by itself, which all of these have A by itself. But the problem is this A squared can't just change to A without doing something. And this something is the square root. Okay, so that means that on these last two, you can't just have this written this way without that square root symbol. So it had to be either A or B. And then we know that we subtracted that B squared, so it's got to be the one with subtraction. All right, on this problem, we checked each one. We plugged in each set of information or side links that they gave us for each person. And we noticed once we did Marissa, it worked. It's the right triangle. Berta worked. It was the right triangle. And if you look at our answers, they're each individually or all three. So we're assuming at this point, if both of these worked, that this one's going to work too. And it does. So that's why your answer choice should be all three. All right, on this one, they were asking, they said they have several different lengths of sticks. She wants to use 3 of them to make a right triangle. Which should she choose and why? When we were going over this in class, we looked at these explanations, I told them, because the explanations themselves kind of point out what the answer is. Because you can't just add the 2 lengths together and see if they equal the other ones. Remember, we have to square them. This one says because they're the 3 shortest sticks is why. Well, that doesn't make any sense. This one shows you that you have a leg squared, that's equal to a hypotenuse squared. That's why this one is your answer. Because I could justify that using these 3 lengths could form that because I can plug it into the Pythagorean theorem and it ends up an equal amount. This last one, we definitely don't want anything that has the less than symbol in it. It has to be equal. All right, on this one, we just did the same thing. Worked everything out, plugged, make sure we put the largest side in C, and we multiplied. We worked everything out, excuse me, and then seeing did it give us an equal value or not. So, and mark it yes or no based on that. So the first one did, so it's yes. Second one did not, so it's no. Third one did, yes. Fourth one did, yes. The last 2, neither one of them did, so they were both no's. So you're just plugging it in. A squared plus B squared equals C squared. Make sure you put the longest side in C squared. and you're seeing if the sides equal. All right, these last two are just review problems based on how we use these pictures and we solve for a missing value. I told them anytime they're asking for a diagonal, they are asking for your hypotenuse, which means that you're solving for C. So all I did was plug in the values that I knew. I squared them, added them together, then took the final square root. So your answer was C is equal to 5 for your diagonal. All right, last one, they give you a picture of a scenario. They're talking about the ladder. They give you information for how far it is away from the base of the diving board. They tell you how far up the diving board is. And they want to know this ladder, but the ladder is your diagonal. So we plugged in all our values, and we noticed that this word said approximately. So remember, that tells me that it's probably not going to come out to a nice, neat number. It's probably going to be a type of decimal. And it did, because at the very end, when we had to square root 125, it gave us 11 point, let's see, this gives us 11.18033 and so on. So if we're saying approximately, that's why we chose 11 feet. Okay. All right. If you have any questions, let me know. If you do not have any questions for first and second block, this is your code. And then for 7th and 8th period, your code is 902912. So make sure you go there. It's the same exact questions, and I want you to enter your answers into Master Connect for me that we've went over. Thank you.